Welcome back to physics. Today we're going to move on to Newton's second law. So we already talked about Newton's first law in class, which you should remember was also known as the law of inertia. And now we are going to move on to talking about Newton's second law, where we're going to start doing a little bit more math.
Now, Newton's first law was very wordy. Like the actual definition, it had a lot of words in it. This one is very simple. Newton's second law is F is equal to m times A. That's it. I mean, we could explain it in words, which we'll kind of do, and you should probably write down, but this is the law. And basically what it says is force is equal to mass times acceleration. You could solve it for other things, like you could say, well, acceleration is equal to some other stuff. And that's kind of the way that Newton did it back when he came up with this law. But the way that we remember it is very simply, F is equal to m times A. So let's go through some of these things. Let's talk about mass first. M is mass. What is mass?
Mass is the amount of stuff inside of an object. So we were talking about mass being related to inertia during this past week with Newton's first law. And it's really just how much stuff is in that object. So when you are moving around, when you are walking up and down the stairs, when you're going to a different planet, your mass isn't going to change.
Now, this is not a very technical definition. I know I wrote the word stuff, but really it's the amount of matter in an object. So things that have a lot more matter stuffed into them would have a lot more mass, also depending on their volume. So it's really also kind of related to density. The more dense objects are, the more matter they would have in smaller amounts of that stuff. So mass technically is just how much stuff is in you.
So when we talk about mass, we do have our standard units for mass, and our standard units for mass are kilograms. So every time you go to plug some number in, or you're doing some sort of a problem, you need to make sure your mass is in kilograms first. So that's where those unit conversions might come back into play.
I just want to stop for a second. Anytime you see one of these brackets, we're talking about the units of that thing. So here, when we talk about mass, in brackets, we rewrite kilograms. And then when we figure out what the unit for force is, we'll put it in brackets. So anytime you see bracket, that means the unit of that thing. Alright, so let's go on and talk about acceleration next. Well, what's acceleration? It's kind of difficult because we haven't really talked about velocity yet, but velocity is technically speed, like how fast are you going? And an acceleration is a change in your velocity. So we'll write that down. Acceleration. Terrible handwriting.
And spelling, but that's okay.
That's a C. C.
Acceleration.
Whatever. Change in speed.
And when we talk about change in speed, we're actually talking about the rate of change of speed. So how quickly or slowly is your speed changing? And when we talk about the units for that, we talk about meters per second squared.
Okay, now that may be a little confusing, but basically what it means is meters for every second times seconds. Okay? So what happens is you'll start out at some speed of, let's say, 1 meter per second. Right? That means that for every single second you have traveled 1 meter. Or in other words, you have traveled 1 meter in 1 second. Well, let's say you start accelerating and now you do 2 meters per second. Well, you've accelerated by 1 meters per second in that 1 second. That's where this seconds squared comes from.
If you aren't fully comfortable with that definition of acceleration yet, don't worry. We're going to continually define it, and we're going to look at what that then causes a change in and talk about that change in speed later on as well. So don't stress over that definition just yet.
Okay, good. So we got that stuff down. So now let's talk about what would be the unit for force. Well, luckily, since we've already figured out what the unit for mass is and the unit for acceleration, we can just multiply the two. It's just like sitting in algebra class and taking x and multiply it by y. You would just write xy. Well, the same thing happens here. So we have kilograms times meters per second squared. So an acceptable unit for force would be kilograms meters per second squared. There is another one. Yeah, it's a lot.
I don't want to write that every time. That's way too much work.
But there is another one, which you should have figured out from the Introduction to Force Lab that you've already done. Our little scales measured things in a different unit, and that unit was newtons.
So you saw a capital N for all of the numbers that it was showing you. And that stands for newtons because this is Newton's second law. So he's the one who really figured out this relationship. So he got a unit named after him.
Physicists are lazy. We don't want to write kilograms meters per second squared every single time. So we said, let's just make up a new unit. And we said that, well, 1 kilogram meters per second squared is equal to 1 Newton. Made it short.
So anytime you're solving a problem, you can always say your units for force are newtons. If you forget that and you don't always remember it, you can always go back to just doing the math and getting kilogram meters per second squared. Now, we talked about your reference table. You all have your reference table or your best friend. And on the back of your reference table, that very last page, is where we're going to start looking at all these formulas. If you look on the back of your reference table, you will see the equation written like this.
It is the same equation. And in fact, it was a question on the math test. Okay?
Okay.
So all we did here is we solved this equation for A. Some people did it wrong in the math test. I hope you figured out how to do it by now. But basically, you're going to divide here by M, divide here by M, and you're left with A is equal to F net over mass. Let's talk about what this net means. What does net mean?
So net means your overall force, or the sum of your forces, what you're actually experiencing. Okay? So right now, as I'm standing here, I have no net force acting on me. Okay? All of my forces are balanced, and I don't feel like there's any force acting on me. However, if this floor just disappeared out from under me, then I would have a net force. So we'll talk about all the different types of forces, but that's the sum or the overall force that you are feeling.
Okay, so let's finish with an example. A very simple, easy example. So let's say we have a force of, let's say, 10 newtons applied to a mass of 1 kilogram. The question could ask, what's the acceleration? What do you do?
So our first step, now that we have all of our information written out for us, is we want to write down that equation. Because we want to know exactly what we're plugging into and making sure that we have everything written out. So I'm going to write it how I would pull it off of my reference table, which would be A equals F net over M. And then I can start plugging those in. I have to be careful and make sure that I'm plugging in my units when I do plug those numbers in. So I have a force of 10 newtons divided by a mass of 1 kilogram. And then you can do that math and get 10 newtons per kilogram. If you just look at your units here, you can do the same math that you do. You do 10 divided by 1 gives you 10 newtons divided by kilogram. Or you can remember that it's also meters per second squared.
Good. So here I've got all my given information written down. I've got my unknown. That's the thing that we're looking for. And here we have written the equation. And then over here, we've substituted and solved.
So this is a method that we are going to continually practice this entire year, called the guess method. So we have givens, unknown, equation, substitute, solve, G-U-E-S-S, you gotta guess. Okay? So on every single physics problem you do, you should be trying to follow this guess method. Okay? And we're gonna talk more about that and make sure that when we're looking at our solutions, we're finding, okay, where are my givens, where are my unknowns, write out my equation, substitute, and solve.
As a final question, what would happen to the acceleration if the force was doubled?
So you're going to try that. We'll talk about that when we come back in class on Monday. And any other questions that you guys have, please ask.
As always, have a great night.